Good morning, students.
Good
Good
morning,
morning,
madam.
ma'am.
Good morning. In the last class, we learned this Minimax procedure and name game. Did you try name game? There is a game called name game. So today, at least you try how to play that and how that can be modeled in the form of a tree like this or a graph. That is how a player can win. There are two players who can win, who can lose, when they can win, how many matchsticks decide the winning or losing, and the turn of the player. If he's the first one to take the move, is he going to win, or the one who is taking second, is he going to win? Although there are so many aspects of that. Please, on page number this all are part of name game. Here 3.3.3 78, page number 78 to I think 88 or 87, that is name game. Please go through that. And also we looked at the Minimax procedure yesterday. Minimax procedure is this is the strategy in which the max player, there are two players, max player and min player. Max player tries to maximize his score and min player tries to minimize max score. So there is a player and the opponent. When he is taking the move, he is the opponent. They are opponents and they are players. And here, when minimizing, when it is a minimizing level, that is a minimizer's turn. It generates successors and apply minimax to the successor and return the minimum of the result. The least value it will return, so that the max player would not get the highest score. And here, when it is the turn of max player, then what max player does is it generates the successors, apply the minimax to each successor, and return the maximum of the result. And we looked at this example. These leaf level values have already been given. Based on some criteria, these values are given. Further, here the max has to pick up a value out of the given values. In this path, there are two values, 2 and 5. Which value max would prefer and choose? 5. Because out of 2 and 5, 5 is maximum. Max goal is to choose the maximum value. And out of 5 and 7, to this min player will choose 5 because 5 is minimum. Somehow min try to make the max get low score or lose, and max tries to gain by choosing the maximum value and win the game. This is only one single, and out of this 6 is max. Out of 6 and 3, 3 is minimum, so minimum is choosing 3. Out of 2 and minus 2 is minimum and 2 is maximum. So max has chosen 2 through this path. This is joining here with minus 2, and min would choose minus 2. This minimax procedure. Moving ahead to alpha beta pruning. This is a strategy which will remove. Prune means removing. Removing some of the nodes that would not lead to the success. If some of them are pruned, then it would become easy uh, to evaluate, and in terms of memory, it would occupy less space. So the strategy to reduce the number of tree branches explored and number of static evaluation applied is known as alpha beta pruning. This is one strategy that is used to reduce the number of tree branches and the number of static evaluation applied. This procedure is known as backward pruning. Alpha beta pruning is known as backward pruning. In this method, there are two threshold values. One represents the lower bound alpha, or on the value that maximizing node may ultimately be assigned, and another represent the upper bound on the value that minimizing node may be assigned. Maximizing node, uh, what is the lower bound on the maximizing node? Max nodes would be there. No, these are in the level you have some max nodes and some min nodes. Max nodes, what is the lower value, lowest value? That is lower bound alpha, and min minimum min nodes or minimizing nodes. What is the maximum value upper bound? That is beta. These two values are assigned. For example, in this max, if it is 2, then what is the value of min? It should be less than or equal to 2. Min goal is to choose a value which is less than or equal to 2, because max has chosen 2. So min goal is to choose a value which is less than or equal to 2. Alright, this is alpha beta pruning algorithm in which max chooses the lower bond, min chooses the upper bond. For max, more than 2 is also okay, but 2 is the lower bond. And then when you choose alpha 2, the upper bond value for beta is 2.
Sorry for the interrupting, ma'am.
No problem, please go ahead.
Ma'am, here you said lower band mean minimum value.
Hmm.
Here
Yeah.
to up to below 2 it is a less value, and minimum value. 2 is a maximum value, ma'am.
2 is the maximum value.
The
Hmm.
lower band values will come only less than or equal to 2, ma'am. Is it correct, ma'am?
Uh, Srinivas, first, did you understand max and min? What is the goal of max and what is the goal of min?
To show the maximum value.
Actually, we are learning game playing.
Mm.
Okay, game playing like chess or
Okay.
any other game. In this, there are two players, max player and
Min
min player.
player.
Max player goal is what? To maximize his score.
Uh,
That is the goal of max player.
yeah,
What
ma'am.
is min player?
Minimize the maximum value, ma'am.
Yes, minimize the value that max chooses.
Yeah, ma'am.
That is min goal.
Okay.
Here in this case, when max has chosen 2,
Mm.
okay, what is the goal of min? It should be less than or equal to 2, no?
Yeah,
Any
ma'am.
other value. If you consider uh, this tree here, if max has chosen 5, so what minimum value, what it want?
Below 5.
5 or below 5?
Mm.
If there is any other option below 5, then it chooses that.
Yeah,
But
ma'am.
here, because it is 7, so it is choosing 5.
Yes,
Like
ma'am.
that, uh, so Srinivas, like that, what is happening? Because it is choosing 2, here min
Mm.
is less than or equal to 2.
Yeah, ma'am.
That value pin would choose. If there is
Okay.
anything else, it prunes. Prunes means removes. Why it removes? Because there is no meaning of having that. Why there is
Yeah,
no
ma'am.
meaning? Anyway, min is not going to choose.
Okay, ma'am.
And for max, if 2 is the maximum, 2 is the bond, lower bond,
Mm.
then if there is anything less than 2, that is not of any use for max.
Yeah, ma'am.
Because,
It's
because
already less than 2, ma'am. It minimum value.
minimum wants less than 2 or 2.
Yeah, ma'am. Yeah, ma'am.
Maximum wants 2 or more.
More.
If it is
Yeah,
less,
ma'am.
it may prune. Prune means remove.
Okay, ma'am. Now
Uh,
clear.
Now clear?
Mm.
Okay. You look at this figure 3.23, alpha beta pruning algorithm, step 2. When Max has uh, chosen 2, min has chosen 2 because the other side it is 7. It has chosen 2. What Max goal is now to choose greater or equal to 2. If there are any other path, then Max would want to choose a value which is greater than or equal to 2. In the third step, here out of 2 and 7, min is choosing 2. Out of 1 and here there is no value given. It wants less than or equal to 1. And out of these two, Max is choosing 2 because 2 is higher. Here it would come 1 or less than 1. In the next step, as we are expanding this tree, you see here G has been pruned. Why G has been pruned? Actually, G has been removed. Perhaps G has a value which is higher than 1. So the min uh, node would not choose anything going this path because its criteria here is less than or equal to 1, and here it got 1, it gets 1, it chooses 1, and here whatever is the value, it is not considered. Here for min, it is equal to 2 or less than or equal to 2. For max, it should be equal to 2 or greater or equal to 2. For max, this is the lower bond, alpha. For min, it is the upper bond, beta. Upper bond is 2. Here lower bond is 2. Lower bond is 2 means it is open for any other value greater than 2. That's why it is lower. It means 2 is not the maximum value, rather it is the minimum value. We can get, if you get 5, 5 is greater than 2, yes, and 2 is the lower bond. 5 is greater, so 5 can be chosen in case if such scenario arises. And then finally, a game tree is built with a branching factor of 3. Can you analyze this? Can anyone analyze this and explain it? Let us start from here. The leftmost part of the tree. In the leftmost part of the tree, we see the level denotes max. Here there are leaf values which are already been assigned. For this max, out of 8, 7 and 3, what will be the lower bound? Max chooses lower bound. It should be, actually it is chosen 8, and it, the bond lower bond is greater or equal to 8. Greater out of it, greater or equal to 8, it is chosen 8 because out of 8, 7, 3, 8 is only the highest. This max has chosen this. At this node, the goal is greater or equal to 9. Because the goal is greater or equal to 9, these are 1, 6. These 1, 6 values can be pruned, can be directly removed. There is no need to explore because the bond is greater or equal to 9. Here in this case, it is greater or equal to, first it is greater or equal to 2, then 4 has come, greater or equal to 4, and here it is not greater or equal to 4, so equal to 4 it has chosen. One by one it is traversing. It has chosen 4. Here, first 1, greater or equal to 1, that is the lower bound. After exploring 3, it finds that 3 is greater than 1. So, next value can be greater or equal to 3. Finally, it is 5. 5 is greater or equal to 3, so it has chosen 5 for this node. At this node, 3 greater or equal to 3. Greater or equal to 3, 9 is satisfying that condition. 9 is greater. 9 is greater or equal to that bond is specified, lower bond. When 2 comes, 2 is not satisfying this criteria, so 2 can be removed. And finally, here it would be 9. 6 greater or equal to 6. These two are less than 6. So there is no meaning in continuing here. Here, greater or equal to 1, 2 is satisfying, so greater or equal to 2, 3 is satisfying, so equal to 3. Now this part is not at all required. It is totally pruned when it comes to min. In min, what happens? Min bond is less than or equal to 8. Less than or equal to 8 is the upper bond. And after going through this is not uh, less than 9, less than 8. This is not less than 8. Next one is 4. 4 is less than or equal to 8. It is choosing 4. 4 equal to 4, this value. This side, it should be less than or equal to 5. And no other node is satisfying this condition, so it is equal to 5. Here it should be less than or equal to 3, and you see here this branch and this branch, no need actually. Here, even if you choose 9, if you choose 16 here, if it is less than or equal to 3, there is no meaning in traversing to these two paths. That's why these two paths are pruned. Out of these three, it's turn of max player now. Max player, first put the bond greater or equal to 4 because here it is 4. When it encounters 5, it puts the bond as Lower bound is greater or equal to 5. As it moves to this next node, it is less than 5, therefore 5 is chosen as the final value. Is this clear, students? And this alpha beta pruning effectiveness depends on the order in which they are examined. If this order, the middle one is examined first, here it would be 9. Then perhaps this and this can be pruned. In what order values are specified and in which order this traversal is performed, depending on that, the effectiveness is evaluated of the alpha beta pruning algorithm. What is algorithm? Minimax, alpha beta, position, current position, depth. What is the depth here? In this, the depth is 3. Player, max player or min player, alpha and beta. These are the two upper and lower bound values. If depth is the present position, then it returns the path. Eval, it does evaluation and it returns the path. Otherwise, it generates the successor. GEN means generates for that particular node, it generates the successors. If successor list is nil, then it returns eval and stops. Otherwise, if there are successors, for each successor in the successor list, if successor result is equals to minimax alpha beta, successor depth plus 1 means again it is a recursive call. Successor depth plus 1 means present node, whatever successor is, dot depth plus 1, the next one, because we have to check in this manner only. No? For this, we check its successors and player beta alpha new value is equals to value of successor result. Here, when we look at 8, and if we put the bond greater or equal to 8, and when you go to next successor, if it is 9, so here you say that greater or equal to 9. When you move here, it is 1, then you say equal to 9 because 1 is smaller than 9. That is new value of the successor result, whatever is the value. If 9, because it is the higher than 8, that value new value is 9. If new value is less than the present value, in case if new value is greater than beta, then what is beta? Beta is the upper bound, alpha is the lower bound. If new value is greater than beta, then beta equal to new value. And the best path is added to the result. If beta, alpha, then return um, beta value and best path value. Finally, it returns the beta and the best path. Here we can see that for this, the best path would be it is going to 5 this way and this way. This 5, this and this. All right. Then refinement 2, alpha beta pruning. What else we can do to make it better? Pruning of slightly better paths. Here we see that value 4.2 is only slightly better than 4. So we may terminate further exploration of node C. Here node C, here we know that it should be greater or equal to 4, and here it is less than or equal to 4.2. Further, no need to uh, traverse, because we got some higher value, and because min says that it is less than or equal to 4.2, it means that whatever value is ahead, that is less than this one. All right. That's why no need to proceed further. This is known as futility cutoff. And here it is, this side also, if it is whatever limit min is posing, if it is not able to, if it is 5, this is min, and here max wants greater or equal to 5, this is 5, it means that it can go to another path and see whether it can find greater value greater than 5. If it finds 7, then it chooses that value and ignores the other path. That is known as futility cutoff. Waiting for quiescence. This is if this is the tree, first level tree, and this is the expansion. After expansion, we see that the estimate of the worth of B has changed. Earlier it was 6. Now, because consider this to be min. Min has chosen -2, because -2 is less than 6 and min goal is to choose the minimum value. And therefore here B is not the good move. If in case such changes would occur, then we should not move further in that path. And such type of situations is known as, we should continue the search further until no such drastic change occurs from one level to the next, until the condition is stable, and such situation is known as waiting for quiescence. Waiting for a stable situation is known as quiescence. This is not stable. Why it is not stable? Because it might change. If suppose it will not change, then it is said to be stable change. Next one is this extending unstable node to obtain stable condition. Further, this node is extended to find whether any stable condition exists. Because the stable condition exists, uh, now this tree can be considered as a stable. A secondary search means uh, to check it again, explore the game tree to an average depth of more ply on the basis of that. And then a particular move is chosen. The chosen branch is further expanded to 2 levels to make sure it looks good. This is known as secondary search. What does it mean? What happens here? Suppose this is a tree. If we consider that the depth is 1, 2, 3, 4. If you call the root to be at depth 1, then this would be at depth 4. If the criteria is to check the tree up to depth 4, here if there is any stable situation, which can lead to the changes of these values to have a kind of assurance that we get a stable condition. In secondary search, further the nodes are expanded to two more levels to check whether uh, further down the line things are acceptable or not. That is secondary search. And alternative to alpha beta pruning minimax procedure is, sometimes minimax procedure have some problems even with all the refinements. So minimax procedure will always choose the bad move out of the two. And here we choose an option which is slightly less bad than the other. This is based on the assumption that the less bad move could lead to good situation. And likewise, there might be a situation when one move appears to be slightly more advantageous than the other, and then it is better to choose less advantageous move because further down the line, this more advantageous move may lead to a bad choice. There are several cases. See, we don't know when consider chess game. When we are playing this chess game, first we take a move and we cannot say for sure what move the opponent would take. And when you are automating this process, computerizing, here you have one move, here you have several other moves after this move. Which one would come, there won't be any idea. And after you expand this tree further down the line, the game might totally change. There might be some situations where mm, we can't predict, where one bad move can lead to loss. There are so many things in a game. Game playing is not easy. It is quite difficult to implement in system and to make an AI system of that. Therefore, alternatives have to be considered when we are coming up with a game solving algorithm. And then here, iterative deepening is one such mechanism. Rather than searching the fixed depth in a given tree, in the minimax and alpha beta pruning, we are limiting to a particular depth. If we say depth is equals to 3 means up to third level only you are exploring. Further you are not exploring. You are stopping at that. Suppose if further you explore, things would change drastically. Who knows? We will not know. There is no idea, no, here what would happen. There are many possible moves. Therefore, instead of searching up to fixed depth, it is advisable to first search only one ply, then apply minimax, two ply, three ply means first move, second move, third move, and final till the final goal is searched. First, you take a move, and suppose max takes a move, then min take moves, apply minimax. Then next max, min, again max for three ply, apply minimax. This is known as iterative deepening. Iterative deepening implies that one after the other procedure is applied. It is not at once. Iterative. That's why it is iterative. For example, what happens for I is equals to 1, for I equal to 1, I less than 10, if you say, in the first iteration, certain statements are executed. In the second iteration, again statements are executed. Likewise here, iteratively tree is built and minimax procedure is applied. Suppose the problems that would encounter in fixed depth solution of minimax and uh, Minimax alpha beta. Is this clear? Any doubt, students? If you have any doubt, you can put in the chat window, or else we will move ahead. These are the questions in the exercise. I urge you all to solve those to get more detailed idea. Also, please study how AI system uh, has defeated the world number one chess player, and how AI system is able to play the game called Go. Go game is the toughest game in the world, and which AI system has won Go game in which year? These all things you please find out today. That was all about the game playing. The next topic which we would be discussing is this logic concepts and logic programming. First of all, what is the need of logic? Will anyone tell me what is the need of logic for AI systems? Here we are learning how to build AI systems. What is logic? Have you heard about propositional logic and predicate logic? What is logic? What is the use of logic? What is formal logic? All right, if I tell you something, at least you can put whatever your answer is in the chat so that I can read, so that it becomes interactive and then this is the logic. You see, first thing, when a teacher explains and asks students, "Do you understand?" And then second, students say yes. Then what inference I made? Third one, I am making the inference. Whatever concepts I explained have been understood by the students. Why I am making this inference? Because students replied yes to my question, did you understand? These are three different statements. Actually, there are two statements. The third statement I am only creating based on the upper two statements. Why I am creating the third statement? By applying the logic. What is the logic here? The logic is to the question, did you understand? If the answer is yes, the logic is that using logic we can solve problems. What kind of problems we can solve? Yeah, Srinivas, very good. You have come up with one answer. So now the next question goes to you is what kind of problems? Where which problems require logic? All right, students. Again, I'll give you one example and then you tell me what inference you make. First, I say that uh, corona cases are increasing. Okay. If I say corona cases are increasing, And second statement I give, uh, educational institutions have been closed. What inference do you make from this? Please respond in chat window. All right. In day-to-day life also we use this. Suppose if I say something to you, means suppose if your friend says something which is not very direct, you will infer what is the meaning of that statement based on some previous uh, conditions and previous situation. You can infer something. Suppose if you have taken some amount from your friend, and then now your friend says, these days I'm short of money. The what does what will be your inference? Your inference will be, okay, do you want me to give return your money? Because you're saying that you have insufficient amount, you may need it. So do you want me to give? That is the question that you pose to you. In day-to-day life, there we make so many inferences uh, based on certain situations and certain statements. Number of inferences are drawn by us. How AI system can draw inference from the statements? That is the topic of study of this chapter. In this chapter, we will study based on what uh, what logic AI system would draw the conclusions or inferences. Again, there is a very popular example in AI that today uh, the weather is cloudy. The weather is cloudy, and then John wanted to play cricket. John wanted to play cricket, and the weather is cloudy. These are the two statements. What inference can be made? Okay, because it is cloudy, he may not be able to play. He cannot play, or even if he start, he may not complete it. That type of inferences or conclusions we are drawn from the statements that are made. Same thing AI system should do. What humans does. This is the logic of the gist of this chapter. There are several techniques. Based on our mindset, we draw conclusions. If a person is very positive, optimistic, for everything he say positive things only because his mindset is like that. If a person is too negative, pessimistic, then he for everything he complains and he take out some or the other problem in every situation. So based on that, we human beings does. But AI systems, there are some methods that we need to study in order to draw conclusions. Those methods we will start next week. Okay, next week we will study. Like puzzle type of problem. Yeah, yes, Kirti, you are right.